Good afternoon, everyone. Today we're going to continue our discussion on multiple linear regression, but first let's have a review of the simple linear regression model that we generated last time. So the function used is LM, which stands for linear model, to identify first the dependent variable, the outcome variable, and then this is associated with or regressed on education. We only have one predictor here, although our data contains several other predictors. So we're just looking at taking a look at this. And then once we have created this, we know that this is a list and this contains several objects. If I rerun this, okay, and then we will have now, okay, sorry about that. Let me erase this first. Let me erase everything. So which means I will have to rerun my wage data set. Here, I'll just rerun this. Okay, there I go. All right, then what we did last time was to create this model, model 1, simple linear regression, only one predictor. So it's a list of 12, okay? And we got the summary, summary of this. So this is where we spent a bit of time. You can actually also, let's say, output 1 can create this. I'm having problem with my R. Output 1 and then summary mod 1. So you're creating an object that represents the summary of our model. Control Enter. So if I check my environment here, okay, now it's a list of 11. So one was removed. So this is a list of 12, while this is a list of 11, but practically the same thing, okay? So tinanggal lang yung first line dun sa task. Output. There you go. So this was just renamed as output, but the same thing, class. There. Okay, so we said, class, that if we get the summary of our model, we have this output, and we looked at this last time. Okay, said that this is the call function, this is the formula, and then these are just descriptive statistics about the residuals, the error terms, and then these are your model values. You have your estimate. This is your betas, beta null and beta 1. This is your standard error of your betas. This is your t-value, and this is your probability. So last time we looked at how the betas are computed, right? So you first compute for this one, which is, we showed the formula last time, which is just the covariance of your x and y, of your dependent and independent variable, and then the variance of your dependent variable. Okay, so sorry, we discussed that last time, di ba, class? Paki-confirm, class, please. Ay, is my screen not sharing? Yeah, my screen is sharing. Kindly confirm, class, if we discussed the formula for the estimates. Yes, thank you. We discussed it. But the others we did not discuss. For example, yung estimate, done yung standard error, hindi. So let's just quickly look at this. But just taking a look at the model, we know that the suggested model is that your wage, okay, I'll just write it as W, should be equal to the intercept, this one, negative 0.9904, make it 905, okay, plus 0.54 times education. I'll just make it E plus. Okay. Now this one is your W hat. This is your predicted model. So I'll call it W hat sub I, depending on the observation. Okay, this is W sub I. So this is the model value. This is the predicted value because we're using the the coefficients suggested by your model. 0.54 times E, negative 0.905. And then how is the predicted value obtained? By substituting E. Okay, so we know that our output, our data has 526 observations. So each of the E that you're going to put here, substitute here, will have its own, each of the observations. Observation 1 has a value. For example, if you check the value of E, education, it's 11 years. So if we substitute 11 years here and then carry out this addition, then you will have the value of your fitted value or predicted value. And that can be seen in your mod 1. Okay. So normally, your actual value will not have the same value, as your predicted value. So we cannot put equality here. Okay? We can only put equality here by adding the difference. Okay. So then now this one becomes correct. Okay, because it's your actual value is equal to your predicted value and then plus your residual. Okay. So what's this class? Your predicted value is the intercept. This is your beta null, okay, plus your beta 1. This is your slope for education times education. Okay, clear so far, class? Clear so far? Okay, so let's just confirm this. So I'm going to, let me clear the drawings. And let's open. Okay, let's open our mod 1. There. Okay, so you have your coefficients here, this one, negative 0.905. Then you have 0.541. By the way, I forgot to mention, class, that, okay, now based on the model, summary model 1, let me just print this again, control enter. Notice that R is not working well today. Okay, so your intercept class said that if we check if this is statistically significant, if the value of your intercept is statistically different from 0, we said that no, because the p-value is 0.187 and it's much higher than 0.05. So we reject the null hypothesis. The null hypothesis here is that your beta null, your b0, which is your intercept, b0 is equal to 0. This is your null hypothesis. And we fail to reject this class by virtue of your p-value greater than 0.05. On the other hand, dito class, your beta b1, this one, the null hypothesis is equal to 0. And we're saying that we reject this null hypothesis because the p-value is way, way lower than 0.05. So that means that we have strong we have strong statistical reason to believe that your education is not equal to 0. Okay. In fact, the average is 0.541. Okay. So now take note that for the intercept, even if it's not statistically significant, we still include that in our model. Okay. But for the predictors, for the independent variables, when the p-value is greater than 0.05, which means it's not significant, then we don't include that class. We don't include that in our model. Okay, so going back to what I was mentioning to you about the predicted value and the residual class, because that's very important. Let me go back. Let me go back to our mod 1. You can see here what's inside mod 1. You have several, this is a list class, list of 12. So what's inside it? Coefficients, residuals, effects, etc. 12 all in all. So for your coefficients, we have this one, negative 0.905 and 0.541. It's rounded off or truncated to 3 decimal places. Okay, then we also have the residuals here. We have the residuals here, negative 1.95, and then we have the fitted values here. So let's just evaluate class. Let's just see if these values are indeed 5.05, no? If this is indeed the predicted value. Fitted value is your predicted value. So we can, let's check it here. So our equation class is, I'm going to write this as wage 1. This is the first so the predicted value for wage 1 class is, what's the formula? It's your negative 0.9 something, right? So we can actually get that from mod 1. Mod 1 dollar, and then you have coefficients. Coefficients there. And I just want to get the intercept first. So that's bracket 1. So this will give us the intercept class. Control enter. Diba? Intercept negative 0.905. Okay, and then I'm going to add plus still mod 1 dollar coefficients, and then the second one is your slope, right? This is for the, if I highlight this, control enter, that's for education, right? And then what do I multiply this with, class? So this is for the first predicted value for observation number 1. What do I multiply that with, class? Class, what do I multiply that with? To get the predicted value for observation number 1. Hello, class. Hello. I'm sorry, class. I wasn't recording. It's one of those days, class, where everything seems to not fall into place. Since the start, kanina pa, I was having problem with R, then something would crop up. So, thankful pa rin ako na we're still here. Things like this happen. Sometimes it's not really the best of circumstances for you for update. All right, so sorry about that. If I wasn't able to record this, I was just saying, class, that we were trying to prove the formula for SE, standard error of the slope B1, and it's equal to this one. So we said that this actual value minus the predicted value, this is your residual, okay? E squared. So actually, class, here, it's your actual value minus your treated value. I could have, class, chosen here, it would have been the same if I just chose mod $1 residuals. Because this is residuals, class, no? Mod 1 residuals is your residuals. I'll just square this. Okay, but this one, what I did was to get hourly wage, which is y sub I, minus this one is your fitted value. Okay, and I had to attach wage here so that it will the code will recognize that hourly wage is coming from wage. Okay, so you can see plenty of ways to do this. Okay, I just chose using the data itself, but we could have chosen a more simple one. Is just get the residuals, mod 1 residuals, and replace this, all of this one, and then just square it. And then this one, class, education, which is our predictor minus the mean of education, and then you square it, and then you get the sum. Okay, and I denoted this as my n numerator, and this one as my denominator, and then okay, perform the formula plus square root of, this is the square root 1 over n minus 2. N is your number of rows. It's not good to put just the value 526. It's better to use n row of wage, and then minus 2, and then times n, then divide by d. Okay, so comment please, class, if you're getting 0.05 something. Good, good. Okay, so we were able, class, to show that you can compute for the standard error given this formula. The standard error of the slope has of the intercept, class, is a different formula. So I'll just leave that to you as an exercise. This one, standard error of the intercept. This one, it has a different formula, different from the standard error of the slope. Okay, good. Thank you. Thank you so much, class, for your feedback. So it was really meant more for increasing our competency as far as computing in R is concerned. We could have just accepted this at face value. Okay. Next class. Next. The t-value is simply the quotient of your beta and your standard error. So this one divided by this one will give us your t-value. Okay, so let's quickly do that. Okay, so here, same thing here, numerator, denominator, and then this one plus. Let me share this with you. So this is our formula. The t stat class is equal to the estimate the coefficient, okay, the beta, okay, divided by the standard error of your slope or standard error of your intercept. Okay, so you're just dividing it class. So that's pretty straightforward. So we already have SEB1. I run this. Okay. I'll not share this with you kasi simple lang naman siya. So let's compute for your T stat. T stat for your let's compute T stat for your B1. I'll just call it T stat for B1 alt minus. So it's equal to class it's a formula. But it's your B1. So in our case, our B1 is our coefficient. So you can just I access that mod, okay, and then coefficient, and then I'll get for the slope, and then divide it by standard error of B1. We have already that one, standard error of B1. Okay, and then what do you get, class? Are you getting the t value for B1? Here the t value is Are you getting 10.167, class? Okay, good. About the others, dalawa pa lang. Three. Okay. Right. So we should be able to compute already for the t value. Once we're able to know the estimate, okay, we can follow a formula for standard error, then just divide it to get the t value. So why are these important, class? It's important to compute for this, the t value and the p value, because we would like to infer whether the estimate for our parameter, whether it's intercept or the slope for the independent variable, we would like to know if they are statistically significant. Now, I said a while ago, for the intercept, even if it's not statistically significant, it's okay to put it there in your formula. However, if your regressor, if your independent variable is not significant, then we don't put that as part of the model. Okay. All right. So if I divide 0.54 by 0.05, I'm going to get this one, 10.167. Okay, so, and there is a basis class for saying that, okay, the t-value class should be, we can say that based on the t-value, it's significant or not. We'll discuss that as we go along. Here, class, in the p-value, we said that the rule is that the level of significance that is always oftentimes used is 0.05. So any p-value that's greater than 0.05 results into a rejection of the null hypothesis. We're not able to show evidence in favor of the null hypothesis. Okay, so let's now we now go, class, to the computation of the p-value. Okay, so this is something more, let's say something more, say not really difficult, but all right. I'll give you a few seconds, class, to research, given an LM output, given the regression output in R, can you extract in the model your t-value? Can you extract class the t-value? And for that matter, can you extract the standard error? Because we were able to extract, right, the coefficients. How did we do that, class? Let me illustrate that again. Remember, just put it here, class. Okay. So model 1, dollar coefficients there. And then what we did was, if you want to get the intercept, that's 1, right? And the slope, that's 2. Okay, if both, class, there. Okay, but take note, class, in the outcome. Okay, where's the outcome? In the outcome, okay, let's once again go here. Let's go to model 1, class. I'm sorry. Model 1. Take a look, class. Coefficients natin are what? Intercept and education, right? Intercept and slope. Okay. However, class, if we print the model 1, class, under coefficients, okay, where's that? Okay, here, class. Sorry. Under coefficients, class, you have estimate. Under coefficients, you also have standard error. Under coefficients, you have the t-value and even the p-value. So if that's the case, can you extract the standard error and the t-value from the model 1 regression output, class? Okay, I'll give you a few seconds to try to figure that out, you can, of course, Google, you can check class if I can extract a standard error of the intercept, standard error of the slope from the model one, from our model output in R. I'm giving you a hint class. The hint class is shown in on the screen. Okay, this is one, no? So Lucille, can you please share your answer to everyone?
Oh, sir, ang sagot po dun I think is you input summary tapos yung pangalan po ng model niyo tapos $ sigma.
Did you try?
Wala pa po, sir. Let me try.
Check nyo muna bago nyo i-ano. Check it first class.
Yes po, sir. Yung value pong nakuha ko is 3.378.
But what's 3.378? What is 3.378? Is it anyone here? Is it the standard error? We're talking about the standard error. Huh?
Yes po, sir. Yan po yung nakuha.
What you showed is this one. Residual standard error yun. That's not what we want. We want this, ito. We're talking about this one kasi, di ba? Estimate standard error of the intercept and the slope. Not the standard error of your residual. That's different. Okay? So what we want is this one. Okay, I give you a clue class. Okay. Didn't we create this object class? Ay, sumagot dito. Alright, pwede rin yan class kaso. Okay. Kaso class, yung square root diagonal variance covariance model 1. Pwede yan. That's a formula, no? We're not here getting the formula. Okay? So the formula class is square root diagonal variance covariance model 1. That's actually the formula to get the standard error. Okay? However, class, okay, if you recall, class, kanina, we created this object right here. This one. Dito lang, I'll just recreate it, class. Here, I'll put it here, class. Then I'm creating this object, output. I'll call it output 1. And output 1, if you recall, class, alt minus, this is your summary of model 1. Okay, run this class, run. And then let's view output 1. View output 1. Okay. So this is also a control enter. This is also class a list. It's a list of 11. We said a while ago, diba? Kanina yung model 1, list of 12. This is list of 11. And take a look, class, at this. You have residuals here. And then here, class, coefficients. And what do you notice about the coefficients, class? What's the size of your coefficients? How many rows, class? How many rows, class? Hello, how many rows? 2 by 4 yan, class. So, how many rows? Class, how many rows? 2 by 4. Here we go again, class. Takes you too long to respond. How many rows, class? Andyan na yung answer, oh. 2 by 4, class. 2 rows by 4 columns. 2 by 4, class. 2 rows by 4 columns. Okay? So if you take a look at our output, class, tingnan nyo. Oh, asan na yung summary natin ng keep on. Ito, ulitin na naman. Yan. Summary ng Model 1, class. Tingnan nyo. Tingnan nyo yung mga coefficients, class. Coefficients. Diba? How many rows yan? How many columns? Yung coefficients, class. Diba? Ayan, no? Right? 2 by 4. So, ibig sabihin, class, yung first column nito, first column, class, you have this one. First column. Second column. Third column. Fourth column. So, yung coefficients na yun, class, coming from your output 1. Okay? So, your output 1, class, it's different from your model 1. Kasi si model 1, class, take a look at the coefficients. Dito ang coefficients, dalawa lang. Okay? Right? Isang row lang siya. Double na dalawang columns, pero isang row lang siya. Okay? And it does not reflect here dito sa sa yung model 1 natin. It does not show here where your standard error is. It shows us the estimate. But when you create an object, kunyari outside the output 1 natin, which is the summary of your model 1 class, what do we get? And we have coefficients. So, okay, and we're just looking at this one, class, for us to master how we can use any yung mga list, class, no? Yung mga list dito. So, for example, once again, class, I'm going to here below, Control Alt I, and then output. Okay, so kanina pa, sorry, naglolo ko tong art ko. Names, output 1. This is really taking me output 1. Okay, so take a look, class. What's inside the output 1? So these are the objects, right? 10, 11 objects. So let's get output 1 $. Okay, here, class. Let's see what happens here. There you go, class. There you go. So we can get this one, class. We can get the standard error, the t-value, the p-value from the object that's created to represent summary of your model. So if you want to get, for example, the standard error, paano natin kukunin yung class? So, ganito ba yung class? How? So it should be the which class? Which column and which row? How will we do this, class? If I only want to get, let's say, tingnan natin class ha. If I put 2 here, class, if I put 2, what will this give us? 0.54. What's that? That's this one, the estimate, di ba? Okay, so my answer 3. Okay, if I put 3, class, what happens? 0.68497. No? Okay. So what's that, class? Third siya, no? So parang nina-number niya 1, 2, 3, 4, 5, 6, 7, 8. If I put here 8, what's that? This one. Di ba, class? So ito yan, di ba? Ito, the 8th element. So that's like a vector, class. No? It's a vector. Yung vector natin, ito yung number 1, number 2, number 3, number 4, hanggang number 8. If I want this to, paano yung class? 3, 4. Okay, it will give me the standard error for, so this is the standard error for your intercept. This is the standard error for your slope. Follow, class? Follow? Feedback, please. Are you able to follow, class? That was my question, class. How do I extract? How do I extract the standard error or the p-value, okay, or the p-value from my model? Okay, so I said what you do is to create an object. Okay, output 1 is the summary of model 1. Okay, because if we use model 1, class, for example, if I use the model 1 object here, and then coefficients 3 to 4, NA siya. No? NA, how do I know, class? Because if you take a look at model 1, the coefficients have only 2 elements there. This one, the intercept and the slope. So we can't get the standard error here from model 1. However, I said that if we use, if we represent the summary of model 1 with an object with a name, output 1, we have it here, class. And you can see here, it's a vector there. Ito yung mga, ano, those are the values. Okay, good. So yeah, thank you, class. So, the objective, class, is just for us to really be more familiar with how to navigate through the, you know. Okay, I need to discuss this now. Okay, so we said, class, that the t-stat is simply your coefficient. So in this case, coefficient number 2 coming from mod 1, this is your slope, divided by the object that we created a while ago, the standard error of the slope. Or, okay, this can also be obtained by t-stat underscore b1. Okay, we know how to do this now, class. It will be from your output, right? My R is really acting up today. Output 1, class. Output 1, dollar, class, dollar. Can get it from your coefficients. And notice, class, okay? Notice the icon here. It's a spreadsheet. Dollar, coefficients. And then what element is that, class? The standard error of your first, it's the, so it should be the estimate, right? Your B. Your estimate is in number 2, and then divided by, and just copy this. Control C, Control V. The standard error is in number 4. Okay. And I can have this printed by putting parentheses here for printing, comma, control enter. There, 10.1 class. Or we could have, it was just meant to illustrate class, no? Or we could have just gotten output one, dollar coefficients, and then the t stat for the slope is the sixth, 6. So there you go. Okay, class, clear? Okay, kindly chat please, class, if it's clear. Good, thank you. All right, now the next one, class, is for us to prove we have to prove this, class. Although we know how to get this one, class, this probability, which is just output one, dollar coefficients number 8. Okay, what we do is now we compute this, class. We can also use R to compute for the t stat. Okay, how do we do that? So we have here your t distribution. Okay, you have your t distribution. So in order to compute for the p-value, class, from your basic stat, what you're determining, class, is really this one. And the t-stat, class, will start with, it will start from the left. The p-value that will be given is the area under the curve. Okay, so what we have to know is we have to know what the t-stat is. Okay, and it's represented by the value q. So do we know that t-stat? Yes, class. It's 10.167 here. So if it's a t distribution, class, okay, it's just like your normal distribution, only it's more fat-tailed. Your 10.167 will be here, 10.167. Okay, and what we're interested in, class, is this one, this p-value. We would like to know this p-value. Okay, this one, because that will be the basis whether to reject or to not to reject our null hypothesis. Our null hypothesis here, class, is that B1, that's the estimate, that's your beta for education, is equal to 0. That's our null hypothesis. Okay, and to answer that, class, we have to know the p-value. Here we know the p-value already, okay, and we know that it's statistically significant. So our inference last time was we reject this. We reject the null hypothesis that your B1 is equal to 0. There's strong statistical reason to believe that B1, the slope for B1 is a value other than 0. In fact, the average is 0.54. So this is statistically significant. 3 stars. Statistically significant at 0.001. So we'd like to compute for this one because we said that it's important for us to understand the anatomy, the physiology of your regression output. So how was this solved, class? So once again, this is your t distribution. We know the t value, this one. So we know that this is 10.167. Okay? So in R, we can make use of the function pt. A pt. So this is the probability for a t distribution. So number 1, class, could you kindly type that? What's being asked? What is being asked? What are the parameters? Could you kindly check that, class? You type pt inside the code chunk and then open and close parentheses. Okay, please. Quick, class, quick, come on. You type inside the code chunk pt and open parentheses, open and close parentheses, then it will tell you, class, what are the parameters there. Number 1 is Class, what's number 1? Kindly unmute, please. Unmute na lang. I don't want to type it, class, kasi mawawala ang drawing, no? So please, anyone, please. Inside your code chunk, you write PT, class, PT, and then open parentheses, open and close parentheses. Then it will show you the parameters that you need. What are the parameters? Ito na naman tayo, class. 2:15 now. Okay, thank you. What's the answer? Sana unmute na lang para mabilis. Okay, Q. Ano pa, class? Ano pa? What else? What's next, class? DF.
DF po, sir.
Okay, thank you. What's next? May NCP, di ba? Ignore na muna natin yan. What's next, class?
Lower tail equals to
Yeah, lower tail. Lower tail, okay? All right, so take a look at this, class. Lower tail, no? Lower tail. All right, Q, class, we know. Q is 10.167. Okay? What's your DF, class? What's your degree of freedom? Ito yun, di ba? That's your N minus K minus 1. This one. N is your number of observations. K is your number of predictors. How many predictors do we have? Only one. And minus 1, class, because you lose a degree of freedom because we're including the intercept. So your degree of freedom will always be N minus K minus 1. Okay? All right, and then ignore this, class, and then lower that tail. Now take a look at our diagram. Lower that tail, class, means either you're computing from this side, okay, to the right. That's lower that tail is equal to true. But what we're interested in here, class, is this one. What's this probability? And this probability, class, is not from the lower tail. Okay, because if it's lower tail, then that means we're computing this area side. And that's not what we want. We want this, class. So we will have to impose that lower that tail is equal to false. Okay, so let me show that now. Let's take a look at, okay, where's our P? Okay, this one, class, right? Let's call it probability of B1, class. Okay, alt minus. So what's first, class? Q. Q is the T-stat. And we created the T-stat, class, diba? T-stat and then underscore B1. Diba this is your 10 point something? Okay, this is what we computed a while ago, right? And then comma, what's your degree of freedom? Your degree of freedom, class, is, we can just put here, n row of wage, okay? And then minus 1, and then minus 1. Okay, that's minus 1 for the number of predictors, minus 1 for the number of, for the intercept, okay? Or that's minus 2. And then we have a lower that tail, class. Okay, 10.167, which is our T-stat, is on the right, class. It's on the right side. Okay, so I will have to put the 10.167 is, it's not on the lower tail, so I'll have to put here false. Okay, could you kindly check that, class, please? Or if you want the lower the tail to be true, then you should be putting this one, class. Okay, first, what did you get here for this one, class? May mali ba ako? Sorry. I forgot to put here the function. Kailangan dito class yung PT, no? Sorry. Kailangan yung PT dyan. Tapos, let's put here para ma-print yung answer. Okay? Tama na ba? PT, open, close. All right. What are you getting, class? Are you getting a certain value, class? Yes. Negative 31? I think that should be negative 22. Clyde. I think yung answer ni Cecil is correct, no? 1.39 negative 22. Let me go enter. So I'm getting there, class. Okay. Or I can use this class. I can make it lower that tail is equal to true, but I'm going to get the negative of my t value so that it's on the left side. And you know that the t stat class, the t distribution is symmetrical. Okay, so I have to put here pt, just like the normal distribution class, and then put here, okay, I'll make this pt b1a, okay, so that we can compare. All right, it's the same class, it's the same. All right, so it's already time, class. I'm sorry I extended. Now, what I'm going to post, class, hindi ko na ipopost sa Canvas, ha. I requested you to please subscribe to the YouTube channel so that you know when I'm going to post it. But I think many of you still have not subscribed. Paki-subscribe na lang, class, no? Para, and then I'm going to post, class, the recording of the previous class. Okay, I'm going to